For part two, I thought best to just talk to you directly about MBT and the theorems. In my own words, the mean value theorem is a function that is continuous and smooth, or differentiable on an interval, and it's and then at some point in the interval, the function is turns into IROC, which is a continuous rate of change, and is exactly equal to the average rate of change. And it's like saying, for example, and for example, it's like saying you're on a bike for 2 miles, and then after 2 hours, you calculate your average speed, and it's supposed to be 10 miles per hour. And the MVT theorem means that at least one moment during that ride, you were exactly riding your bike at 10 miles per hour, even though you were like going faster or slower at other times. Like let's say an hour and 30, you were going 12 miles per hour. And another example is you're hiking, and let's say at 7 a.m. and 8 a.m. you're getting like 700 feet, and the average rate of change of feet is 20 per minute. And according to MBT, like sometime around 7 to 8 a.m., the climb is exactly 20 feet per minute. And then I'm calculating or expressing the fundamental theorem of calculus. Part one, it's basically saying if you take the integral of a function and then take the derivative of that result, you'll get the original function, and it's like kind of undoing each other, like, if that makes sense. Yeah. And in more words, let's say you're tracking how much soda flows through a soda fountain, and let's take that rate of function and kind of integrate that from 0 to time, or x, and you get the total amount of sodas poured. And then you want to take the total derivative of that x, of the amount of soda, to 0 to x, you get back a rate, and then you then find the exact soda flow at that moment. And then another example, let's say your battery for your laptop it's like draining over time. Let's say let's put that as a function, and then you kind of integrate that over an interval, and then you get the total battery used. And taking that interval to a derivative, it gives you the total usage of the data, or the total usage that you gain from the original rate again. Then finally, part two for fundamental theory of calculus tells you how to calculate a defined integral, and it says that to find an antiderivative of the function, and then plug it to the top limit of the bottom function, or bottom limit, and then subtract it. Let's say, like, example, you want to know how far you ran between 1 hour and 1 hour 30, and let's say that's a velocity vt. Then you found that the antiderivative of vt, the amount of time you ran, and plug it into 1 hour and 1 hour 30 of you ran, and then subtract it, and I give you the total distance ran. And then another example will be let's say say you want to know how much money you made in like a job, like at that exact moment. It's rather than the base pay. So let's say you know how much you earn over a day, and your income rate, let's say, is RT to make it simple, to find the income of, let's say, the hours 7 a.m. to 2 p.m. and you want to find the derivative of RT and then plug into the hours. Let's say let's use the 24-hour format. So 7 a.m. it's 7 to 2 p.m. so 7 minus 17, and then you will find the income rate of how much money you made during that time period. And I guess that sums it up for the part 2. Thank you.